All right, you guys, describe in words what the function does to any input. Here we are on 174. So if we are looking at the function f of x minus 3, that means any input we have, we're going to multiply it by 5 and then subtract 3, right? Multiply by 5 and then subtract 3. So multiply it by 5 and then subtract 3. List the steps that will undo this. Well, the steps that will undo this are we first add 3 and then divide by 5. Write an equation for the steps you wrote in part B. Name this equation G. So G of x means that we take some number and we add 3 and we divide by 5. What happens if you compose f and g? Use the function machine diagram at right to evaluate g of f of 5. Explain why your answer makes sense. Okay, so if we put in, if our input for f is 5, okay, if our input is 5, our output is 25 minus 22, okay, and our input from 20, and if we input 22, we get 22 plus 3 divided by 5, which is 25 divided by 5, which is just 5. So if we input 22 here, our output is 5, right? Because we undid the function. If we enter in 5 into one equation that's we undid, right? And then enter that answer here, our output is the same. Our output for the second function is the same as our input for the first function. Okay, because if we look at the first function and we enter 5 into it, we are multiplying by 5 and then subtracting 3, and in the second one we're adding 3 and dividing by 5. They're the opposites of each other. You're going to get out what you put in, and this is what's leading us to inverse functions. That's what happens with inverse functions. Does it want us to compose f of g of x? Let's do that just in case. I wasn't sure if it did or if it just wanted us to do g of f of 5. But if we did g of f of x, okay, so we have g of f of x. Our g function is x plus 3, but instead of x, we put in our entire 5x minus 3. And then plus 3 divided by 5. If we simplify this, this minus 3 and plus 3 cancel, and then 5 divided by 5 cancel, and we get x back, right? Okay, which means we have proved that it is an inverse. At the time you were originally doing this problem, we weren't doing that yet, but since we've already gone through that, I wanted to show you why it worked. All right, for what values of x is the root of 3 minus x a real number? So if you think about taking the square root of something, if I take the square root of 9, my answer is 3 because 3 times 3 is 9. If I take the square root of 16, my answer is 4 because 4 times 4 is 16. But also, like go back up, also my answer could be negative 3 because negative 3 times 3 is equal to negative 9. And here this could also be negative 4 because negative 4 times negative 4 is positive 16. So both of those numbers are the root of this one number. So when we are taking a look at the square root of 3 minus x, well, let me say one more thing over here. This is what it wants you to see. If instead of positive 9, I had the square root of negative 9, what would my answer be? Okay, and the answer would actually be the square root of 3 times negative 1, right? So I can pull that out. So I have 3 root negative 1. The square root of negative 1 is just I, so this is actually 3i. But 3i is an imaginary number, right? So this question is asking for what values of x is the root of 3 minus x a real number. Well, we know that in order to be a real number, we cannot be taking the square root of a negative number, because if we take the square root of a negative number, maybe you were thinking, oh, the square root of -9 is -3, but we just kind of went through why that's not true. It's because the square root of +9 is -3, because a negative times a negative is a positive. Okay, so we just need to figure out what numbers can I put in for x that give me positive numbers, right? That's what it wants to know. So let's start with 0. If I put in 0 for x, do I get a positive number back? And I get the square root of 3, which is not rational, but it is still positive, so that's okay. If I put in 1, maybe we should start making a table. If my input was 0, my output was √3. If my input is 1, I get the square root of 3 minus 1, which is the square root of 2, which is still not rational, but it is positive, so that's okay. It is real. Then if I put in a 2, I get the square root of 1, which is just 1, which is fine. If I put in 3, I get the square root of 0, which is just 0, and that's fine. If I put in 4, here's where things get crazy. If I put in 4, I get the square root of -1, because 3 minus 4 is -1, and that's that's imaginary. Okay, and any number bigger than 1, my negative numbers are just going to get bigger, right? So that's the square root of -2, which is also the square root of 2i, an imaginary number, right? So what are we looking at? Where is x greater than a negative number? Or where is, that's not what I meant to say, where is this, the output of these values real? And it starts right here. 0 is still a real number, right? But all of the numbers in between, it can't be 4, but all of the numbers in between 3 and 4 will also give you positive numbers. So what we're going to say is x is real. No, the output is real. I keep saying x. The output is real for x less than 4, right? For any value less than 4 but not equal to 4. And if you wanted to write that in interval notation, you would say x is real from -∞ to +4. Okay, and then it's this round parenthesis because it's not going to be equal to 4. But anywhere on the number line between -∞ and +4, okay, and that's not really -∞ right there, that point. It just means that we're going towards -∞ that way. But x is going to be real values anywhere in there.